Welcome back. We're going to start doing study guide number 2. Your midterm is coming up, and this is your kind of last chance to practice. So let's put in the work. Okay. So number 1 wants me to find f of 3 plus g of 2. This is back in unit 1. And I'm going to draw a line here, keep our numbers separated. But first, it wants me to find f of 3, and then I'm going to find g of 2, but we're going to take it one at a time. So initially, let's find f of 3. Like, what does that equal? Well, this is my f of x function. So if f of x is 5x plus 4, then f of 3, I'm just going to substitute 3 right into here, and I'm going to substitute 3 right into here. So f of 3 would be 5 times, not x, but 3 plus 4. Which is 15 plus 4, which is 19. Similarly, I'm going to do the same process now, but finding g of 2. Okay, well, here's my g function. So g of 2, I would simply replace the x, like I've already done here. G of, not x, but g of 2 is going to equal 2 times 2 minus 3, which is 4 minus 3, which is 1. Now in my final step, I'll put them together. So f of 3 was 19 plus, and g of 2 was 1. So our final answer is 20. Okay, let's do the same thing for number 2. So you're going to have to forgive me because I don't know how to use the eraser on this. It's like not actually erasing. So let's just pretend like I didn't draw 3s everywhere and vandalize the screen. And we'll just start again. Okay, so we're going to find g of 2. Circle it, like let's focus there first. So find g of 2. Hey, we already found it over here. We just plug 2 into our g function, and 2 times 2 minus 3, I'll show the work again, was just 4 minus 3, which is 1, which confirms what we had gotten over here. Next, we're going to find f of 1. So f of 1, I'm going to plug in 1 into f. That's 5 times 1 plus 4, which is 5 plus 4, which is 9. And now in my last step, all I have to do is put those pieces of information together. So I want a g of 2, which is 1, minus f of 1, which was 9. So my answer, -8. All right, next slide. Next problema. Let's go. All right, so this one is called, if you look back in your yellow book, it's called a composition of functions. This is when I stick one function inside of another. So here's how I teach my kids. It might be helpful for you. Instead of all of this craziness, I'm just going to rewrite this very simply as f of g. Okay, and what this means is anywhere that I see an x in f of x, this is my f function. Okay, now anywhere that I see an x, instead, I'm going to just put the letter g. So I'm going to plug g into right here. This guy, actually right here. This is my g function, and I'm going to plug it into f, like that. So well, f of g is going to be 5. Now instead of x, I can literally write g plus 4. And then in my next step, I'm going to replace g with what I know it is, which is 5 times. G is 2x minus 3 plus 4. So now I've effectively plugged in g, which is this function, inside of f in place of x there. Okay, now I just got to simplify. So we're going to distribute this. That's 10x minus 15 plus 4. And I will combine like terms. Final answer is 10x minus 11. And that would be f of g of x. Okay, this notation, you may recall, is called inverse. So I want to find the inverse of f. So I'm going to focus over here. It's my f function. And if I want to find its inverse, you should recall that inverse basically means we're going to, like if we have multiplication here, 5 times x, then our answer should be division. And if I have addition here, that means that my answer should have some subtraction. It's basically I want to undo this function. So the way that we'll do this is, first of all, we're going to rewrite f of x as y equals 5x plus 4. Okay, so rewrite it first. Second step, we're going to switch x and y like this. Literally, wherever there's a y, I'm going to write x. And whenever there's an x, I'm going to write a y. And then I'm going to start solving for y. Get y all by itself. Well, it's usually easier to get things by themselves to solve for a variable when it's on the left side. So I'm just going to write my equals x over here. And now it's easier for me at least, and for a lot of students, now to get y by itself now that it's on the left. So to get it by itself, first I need to minus the 4 on both sides. I get 5y equals x minus 4. And I'm going to divide both sides by 5. So y equals x minus 4 all over 5. And yeah, you can just leave your answer like this. So we're almost there. In our very last step, we have to rewrite our answer in inverse notation. We have to actually explicitly say, hey, this is the inverse of my f function. So in the last step, we'll rewrite this as f inverse of x instead of y equals x minus 4 all over 5. And as a quick check, let's see if all of our inverse operators are in place. So f of x had multiplication. Now it's got some division. F of x had addition. And now we have our subtraction. So at least we can check that this does make sense and we didn't make a silly mistake with the wrong operators. Ooh, these ones are fun. All right, solving an absolute value inequality. So the first thing you want to do with these absolute value pieces is get the absolute value all by itself. So you want to isolate your absolute value function. And then second, you're going to branch into 2 different pieces. Okay, so let's begin just by isolating this piece. So I have negative 2 times my absolute value, and then I have my absolute value plus 20. So which one do I get rid of first? Well, if I had this problem, and I needed to get x by itself, I would minus the 20 first, and that's easy to see. But over here, students get a little more confused. So I want you to think about, okay, if this was just an x, what would I get rid of first? And look how I replaced it with an x. Well, I would minus the 20 first. So same here, you're going to get rid of the 20 first. So, what happened? I'm so lost. Here we are. So it's minus 20 on both sides. I get negative 2, absolute value 2x minus 7 is less than negative 10. Now you may be tempted, and I've seen this so many times, you may be tempted to distribute this negative 2 like that. That's not allowed. No, big no. These are not parentheses. You can't just distribute inside. You actually have to divide both sides. Like understand that this is multiplication. You have to divide now both sides by negative 2 to get rid of that. And so now what I have left is the absolute value of 2x minus 7. And then over here, I'm left with a positive 5. And what happens to my inequality when I multiply or divide by a negative number is it flips. So now instead of being less than, I'm going to be greater than. That's super important. It flipped because I divided both sides by the negative. Okay, so now that I've got this piece all by itself, I'm ready to branch, as I mentioned before. So on the left, we're just going to bring down the absolute value. We're going to remove it and leave everything the same. Now on the right side, I'm going to just bring down the absolute value as before. Notice this piece and this piece are identical, so the left side stay the same. but I'm going to flip now both of these. So the direction, so instead of greater, I'm going to be less than again. And I'm also going to flip the sign of the number. That's how we branch. So on the left side, everything stays the same. On the right side, you flip these two pieces, the inequality and the sign of the number to the right. Okay, now we just have to solve for x on both sides. So I'm going to add 7. 2x is greater than 12. Then divide by 2. I get x is greater than 6. Here, I'll do the same thing. I'll add 7. 2x is less than 2. I'll divide both sides by 2. I get x is less than 1. Let me see. I think I made a mistake here. No, looks good. Okay, so x is greater than 6. So we got to put an open circle here because it doesn't say or equal to. And then x is less than 1. So here's my 1. And I'm going to shade in the direction indicated. So at 6, I'm greater than 6. That means I'm going to be to the right of 6. And look how this little inequality is kind of pointing you. If you think of it as an arrow, it's pointing to the right, like shade to the right. Okay, that's what you should say. Whenever math is telling you to do something, just say okay and then do it. It's like, okay, shade to the right. All right, fine. Now look over here. Which direction is it saying to shade in? Well, it says x is less than 1, and if you think of it as an arrow, it's like, hey, shade to the left. Okay. There we go. And that would be my final answer. All right. So for this problem, we have to remember a few things. We've got to remember that I is equal to the square root of -1. That I squared is equal to a -1. That I cubed is equal to, well, it's equal to I times I squared, which is -1 times the square root of -1, which is just -I. And then finally, I to the 4th, well, that's I squared times I squared. So it's -1 times -1, which is just +1. So if you keep those in mind, then this becomes really easy. You just have to figure out which multiple of 4 are we on. So I need to see I to the 63rd power. How many times does 4 go into 63? 4 goes into 6 once. So 1 times 4 is 4 minus... Remember that long division? Yeah. 4 goes into 23 5 times. And we have a remainder of 3. Okay. So that means that in this case, I've got my I to the 4th 15 times. So that's basically 15 ones. Okay? 1 times 1 times 1 times 1. And then times that by the 3 leftover i's. I times I times I, which is... Final answer is equal to -I. So let's do this one. How many times does 4 go into 5? It goes in once, and we get a remainder of 1. So if it goes in once, then I've got my I. Let's visualize what's going on. So these 4 turn into just the number 1, and I'm left with 1 I left over. That's 1 times I, which is simply I. Next one, I have I to the 28th. Hey, 28 is a multiple of 4, right? 4 goes into 28 exactly 7 times. So that means I've got 7 groups of I to the 4th. That's 1 times 1 times 1, 7 times. That's just an answer of 1, since we had 0 left over. And I have I to the 106. So let's see how many times 4 goes into 106. It goes into 10 2 times. It goes into 26 6 times. And it's got a remainder of 2. Okay, so if my remainder is 2, that means I've got 1 times I squared left over, and I squared is just negative 1. Cool, cool. Next. All right. So a lot of times people are tempted, when they see problems like this with parentheses, they're tempted to start distributing. Please don't distribute. This is not a multiplication problem. If this said 7 minus I times 13 minus 2, I notice that there's nothing in between the parentheses. That's when you FOIL. But if there's a minus in between, well, then you're doing a subtraction problem. So this is really like a negative 1 here that's going to be multiplied out. So I do not want you at all to be drawing spaghetti straps all over the place. All right, we really have to just distribute the negative and combine like terms. It's much easier than it looks. Okay, so let's recognize that when we're minusing, we're really just multiplying by negative 1, and let's distribute that. Flip both of these signs. So I have 7 minus 8i. Yes, I just got rid of the parentheses because there's nothing being multiplied out in front. I don't need to change anything. And then minus 13 plus 2i. Now I'll combine my like terms. 7 minus 13 is negative 6. And then negative 8i plus 2i. To combine these like terms, we just add the coefficients. So negative 8 plus 2 is minus 6i. Cool. Ooh, now this one, look in the middle. There is no addition or subtraction, so this is a multiplication problem. This is where we'll use FOIL. Okay, so let's start at the beginning. We're going to distribute this first term once and twice. So 2 times negative 3 is negative 6. 2 times 4i is plus 8i. And now I get to distribute my second term. I'm going to do my insides. So 2i times negative 3 is minus 6i. And I'll do my lasts. 2i times 4i is positive 8. And I times I is I squared. Okay, right away, something should be like going ding, ding, ding in your head. You need to remember I squared is actually, I squared is really negative 1. So this is actually saying plus 8 times negative 1, which is actually negative 8. So in the next step, when I rewrite this, I'm going to actually write negative 8. I'm not going to write all this stuff. Negative 6 plus 8i minus 6i minus 8. There. Now we'll combine like terms. Minus 6 minus 8 is minus 14. Plus 8i minus 6i is, well, 8 minus 6 is minus 2. Combine your like terms is I. Whoops, 8 minus 6 is positive 2. Tee-hee. Okay. All right, so solve the following. So I'm solving a quadratic equation. I know it's a quadratic equation because it's got the squared here and it's got an equal sign. So we're dealing with a quadratic equation. The question is how to solve. So you might remember there's a whole bunch of ways to approach these problems. The first thing we should always check is if we can do greatest common factor. Okay. Then, based on the number of terms, if there's 2 terms, you'll want to try difference of squares. If there's 3 terms, a trinomial, then you'll want to try magic x. And if neither of those works, then we'll use the quadratic formula, which is soups fun. All right, so let's try greatest common factor first. So we're going to observe, is there anything that we can factor out of 3, 12, and 15? Basically, the question you should be asking yourself is, what's the biggest number, if any, that goes evenly into 3, 12, and 15? What's the biggest number? Well, 3. 3 goes evenly into all of these numbers. So I'm going to factor that out. So once I've pulled it out, I'm left with x squared plus 4x minus 5 equals 0. For the sake of keeping this simple and easy, I could really just divide both sides by 3 at this point, right? and just get rid of it. So I'm left with x squared plus 4x minus 5 equals 0. If you're in Ms. Horning's or Ms. Gleason's class or somebody else, they might have taught you just to divide everything by 3 in the beginning, and that's totally fine too. You get the same thing. Okay, so let's look at what we're left with. X squared plus 4x minus 5. Well, I have 3 terms, so your mind should immediately be going right around here. Magic x. So I'm going to need to factor this in such a way that I need 2 numbers that are going to multiply to negative 5 and then add up to positive 4, the middle term. Well, 1 times 5 gives me 5. Which one would be negative? That one. So negative 1 and 5 give me 4. I'll write these right here. And now we're going to solve by setting each factor equal to 0. So on the left one, I get x equals 1. That's one of my answers. Now I'll set this guy equal to 0, minus 5 on both sides. And so these are my 2 solutions to the problem, x equals 1 and x equals negative 5. Let's try the next one. Okay, before we do anything, notice that this is not set equal to 0. So this is not allowed. You've got to fix it. Set equal to 0. The way that we'll do that is not by multiplication, not by division. It's always by adding or subtracting. So I'm going to add 2 to both sides. X squared minus 6x plus 2 equals 0. Since I have 3 terms, I'm going to try magic x. See if there's 2 numbers that multiply to 2 and add up to negative 6. Now, if you stare at this long enough, you'll realize there are no such numbers. That means that our final option is to use the quadratic formula. So I'll write it out. X equals negative b plus or minus b squared minus 4ac all over 2a. So let's begin this process by identifying what is my a. That's the number out in front, which is 1. My b is negative 6, and c is equal to just positive 2. Now we're going to plug in super carefully. So x equals negative b, which is negative 6, plus or minus square root of negative 6 squared, yes, put parentheses around the b's, minus 4 times a times c all over 2a. Okay, now we get to do the fun stuff, just simplifying. So x equals, well, negative 6 is positive 6, plus or minus negative 6 squared, that's negative 6 times negative 6, which is 36, minus 4 times 1 times 2 is 8, minus 8, all over 2. Okay, next step, we have to simplify what's inside right here. So 36 minus 8 is 28. I'm going to continue my work over here. X equals 6 plus or minus the square root of 28 all over 2. And as we continue to simplify, it becomes necessary now for us to break down this radical. So whatever method you use, go for it. I want you to simplify it all the way. So what goes into 28? Well, 2 goes in 14 times. 2 goes in again 7 times. And 7 doesn't break down. So I'm focused, I need to pull out the doubles. So that becomes basically 2. And I only write them once. And whatever's left over, which is the 7 here, it goes under the square root. So this is really 6 plus or minus 2 square root 7 all over 2. Now some teachers might allow you to leave it like this. I like to break it up into 2 pieces right now. So here's what I mean. We're going to rewrite this as 6 over 2 plus or minus 2 root 7 over 2, because now by breaking it up, I can actually simplify my answer. So 6 over 2 just becomes 3 over 1, and 2 root 7 over 2, well, you can't simplify the root 7, but the 2's cancel to 1 over 1. So my final answer is 3 plus or minus root 7. Okay, last problem. So it's already set equal to 0. And if I try to do GCF, I notice that there is no number that I can factor out. So I'm ready to go. Since I have a trinomial, I am going to check if I can use magic X. Need two numbers that multiply to 15 and add up to 3. Well, 5 and 3 multiply to 15, but they add up to 8, and negative 5 and negative 3 add up to negative 8. This isn't working out. I'm going to have to use the quadratic formula again. So x equals, let's write it out, plus or negative b plus or minus b squared minus 4ac all over 2a. As before, we'll label our a's, b's, and c's before we begin. So a is equal to 1, b is equal to 3, and c is equal to 15. So we are good to go. Let's plug in super carefully. X equals negative b plus or minus b squared minus 4 times 1 times 15. That's 4ac all over 2 times a. Okay. So negative 3 plus or minus. Now we're simplifying inside of our square root. 3 squared, that's 3 times 3, which is 9, minus 4 times 1 times 15 is 60 all over 2. We have more simplifying to do. Negative 3 plus or minus, well, 9 minus 60 is negative 51 all over 2. And now we're going to try and break down 51. So I don't know about you, but I'm not seeing, actually, 3 goes into 51. Interesting. And there's a few tricks to figure out whether 3 is a multiple of a number, or a factor, rather, of a number. But you can use a calculator to test 2, 3, 5, 7, and numbers like that. But 3 goes into 51, how many times? Let's see. Mm, 17 times. But 17 doesn't actually break down. So since there are no doubles, both of these guys multiply back inside of my square root. And root 51 just stays root 51. But there is this negative in here. And so immediately I'm going to rewrite this as x equals negative 3 plus or minus I square root 51 all over 2. Okay, now we'll break this up into the two pieces. So x equals negative 3 over 2 plus or minus I square root 51 over 2. And neither the left side nor the right side of the plus minus simplifies. So this is our final answer. Okay. So this problem looks scary, but it's really not. It's quite simple. So just let's read what it says. Samantha sketches the graph of this function, x minus 1 whole squared, as shown below. Okay, I think there might be a typo here, because if you observe, this function has a vertex. If we flip the inside and keep the outside. Oh, my pen is tripping. Okay, has a vertex of 1, 0. But this graph has a vertex of 1, negative 1. So I'm going to fix this question. Let's say Samantha sketches the graph of the function f of x equals oh gosh, you're going to have to fast forward through this because my computer is super slowing down. So to show that this is the correct graph, I need to not only shift to the right, but I also need to go down one. So I'm going to make a -1 outside. There. So let's pretend that that's really what the question said. Whoops. All right, she then translates this function to the right 3 units. So that means she's going to go 1, 2, 3. And then 2 units up. So 1, 2. So she's just shifting it. She's not flipping it or anything. So it's going to keep its same shape. It's just going to have a new vertex. So if you remember how to do vertex form, this is a super simple problem. If I told you I had a new parabola at this coordinate point, 4, 1, and notice I got that by literally drawing the shift, then you should be able to flip the inside, figure out what goes here, and then keep the outside number. So I need you to try and figure out what numbers go here and here based on this new vertex. Well, we should get a -4 and a +1. That would give me a vertex that is correct of +4 and +1. Nice. So really, to do this problem, you need to shift as instructed and then write an equation based on the new vertex. Okay. So, last problem. I don't know where it's going, what's going on, but we have one problem left. I swear, this computer thing. I don't know. It's kind of freaking out. All right. Okay, so I lied. We have 2 problems left. No big deal. So, the graph on the coordinate plane shows the parent function. So this is the graph of x squared. And now it says, on this same plane, graph the function g of x equals f of x plus 1. So I don't want you to worry about the g of x. We're basically drawing this new function. We're just giving it a silly name called g. Okay, no big deal. This is the important stuff. We know that f of x equals x squared. So that means f of x plus 1 would simply be, we're just going to plug in x plus 1 everywhere that we had previously seen x. So this is being replaced. Okay, similarly, instead of x squared, it's going to be x plus 1 squared. Well, we know how to graph that. Come on, it's vertex form. Vertex form says flip the inside and keep the outside number. So this is really the vertex of the new graph that they want me to draw. 1, 0, and it's just shifted. So otherwise, it's the same shape. Cool. So really, it's just asking if you can understand that this is just a shift and it's 1 unit to the right. Oh, whoops, I totally got that wrong. Okay, it's 1 unit to the left. Okay, because I've made a huge mistake. Yes, teachers make mistakes. Okay, let me try this again. So f of x plus 1 equals x plus 1 whole squared. So if my vertex is -1, 0, I should actually go to -1, 0. That would be a cool idea. Nice. Okay, much better. 1 unit to the left. So now this matches. Last problem. We're given a graph and we're asked to basically say true or false. Okay, circle the ones that are correct. So if f of x is negative x squared plus 2x plus 3, this is standard form. You got to recall that the way that we check our standard form is we could check the vertex. The formula for that is negative b over 2a. And that will give us the x value of the vertex. And then we plug that in to our y value. Okay, so negative b, in this case, b is equal to 2 and a is equal to negative 1. So negative b over 2a is really negative 2 over negative 2, which is 1. So far my vertex is 1 comma something. And then to get that y value, I just plug in 1 into x. So f of 1 is really negative 1 squared plus 2 times 1. I'm really just plugging it into my x's here and here. And then plus 3. So that's 1 squared is 1 times the negative out in front is negative 1 plus 2 plus 3. Negative 1 plus 2 is 1 plus 3 is 4. So this standard equation, A, gives me a vertex at 1, 4, which matches. Also, notice that that negative out in front right here, oh my gosh, it means that it's facing down. So it looks like we're good on this one. I'm going to mark that as true. And I'm going to erase all this mess that I made. Okay, so circle, yes, that's true. Now we have intercept form. So intercept form, we're checking if our x-intercepts line up. So the negative out in front is a good sign. It means I'm facing down, which I am. And in this case, my x-intercepts are going to be at x equals, we'll just flip this number, negative 1, and at x equals positive 3. So negative 1 and positive 3. Looks like this one is also good. Now, the y-intercept is at negative 3. So let's see, y-intercept means where you're hitting the y-axis. That's my y-axis, that's my x. Well, my y-intercept is really at 3, 0, at positive 3. But C says it's happening down here, which is incorrect. There is no y-intercept down there. So this would be false. D is just reiterating what we already discussed from part B here, that my x-intercepts are at negative 1, 0 and 3, 0. This is why people make mistakes on these. If the question had said this, these would be incorrect because 0, negative 1 is down here. Okay, that's a y-intercept. 0, 3 is up here. Another y-intercept. We want to make sure that our x-intercepts have the numbers in the x spots, not the y spots. So this one's actually true. Okay, now for E, this is called vertex form. Whenever it's in this h, k format. So that negative out in front, that's a good sign. It means that's facing down. And then my vertex would be flip the inside, that's positive 1. Keep the outside, that's 4. Does that match with what we have? Sure does. Our vertex is at positive 1, positive 4. So this one's good. Now look at the difference between E and F. This one also has it facing down, which is awesome. But my vertex is at negative 1, positive 4, which would be right around here. And that's incorrect. There is no vertex there. Oh, so I definitely want to cross that out. That's not true. So my answers that I would say yes, these are correct. My answers would be A, B, D, and E. Okay, hope Hopefully that was helpful. Sorry for the technological whatever was going on. I appreciate you watching the video, and good luck on your midterms.